let's look at the first derivative test. So here we go. Let's read through it, and then we'll look at a few little examples here to kind of really illustrate what's going on. All right, so let's suppose that x equals c is a critical number. And again, this is the first derivative test because it's going to involve information about f prime. All right, so let's say x equals c is a critical number of our continuous function f. And there's really three things here to consider. If f prime changes sign from positive to negative at this critical number, then we have a maximum, local maximum. If f prime changes sign, so it goes from negative to positive, then we have a local min. And if f prime does not change signs at x equals c, so it goes from positive to positive or negative to negative, then it's neither. It's not a local extreme point on our graph. All right, so this is the statement of the test. How do we actually kind of implement this? Well, we see that it involves knowing the sign of f prime. So the context and way we generally do this test is we're finding the intervals of increase decrease. We're finding the sign chart for f prime. So it's going to be very similar to the work we do for those intervals of increase decrease. We want our sign chart for f prime. So let's look at this first graph here. This one is definitely a local max. And it's at x equals 2. And so if we were going to be doing this, what we would have is we would have a sign chart written out. We would have found that x equals 2 is a critical number. And because this is kind of a nice gradual change here in the slope, it's a nice kind of smooth or rounded change here, the derivative is 0 there. And we would have been doing a sign chart for f prime. And we would have been looking at intervals on either the left side or the right side and seeing what that tells us about our original function f. So if we look at this graph, on the left side, on this section over here to the left of x equals 2, our graph is going up. So the slopes are positive and our function is increasing. Now if we look at the other side, what's going on over here? Well, the function's decreasing. The slopes are negative. So f prime would be negative and f is decreasing on that side. And so what this first derivative test says is we would have had this sign chart, and how we can kind of remember this test is once we have our sign chart filled in and we've figured out what f is doing on either side, just kind of draw in what f would look like or something what f would look like. So if f is increasing, it's going up. And then at x equals 2, what happens? Well, it changes and it starts decreasing. So draw that in. And, you know, it's a really rough sketch. We're just kind of getting a really rough picture here. But this captures enough information and it helps remind us that, yeah, if we're increasing on one side and we switch to decreasing on the other side, then we draw in what that looks like. It's a local max. So that just kind of helps remind us, if we didn't have this picture right in front of us, what this test is saying. Now let's look at the next one. So here we have another graph. This one's definitely a local min at x equals 2. Again, it's nice rounded, so the derivative would be 0 there. So x equals 2 is a critical number. And what we would have been doing, even if we didn't have this picture, we would have a sign chart going for f prime. And x equals 2 is a critical number, so we would have plotted that on our sign chart. The derivative there is 0. And then we would look at the intervals. What is f prime doing on the left? What is f prime doing on the right? And so on the left side, our graph is decreasing. The slopes are all negative. So f prime's negative, and the original function f is decreasing. And then on the right side, what's going on over here? While our function's increasing, the slopes are going up. The slopes are positive. So positive and increasing. And so if we didn't have this picture to kind of really, we can identify this just by looking at the picture. If we didn't have this picture We only had this sign chart. How would we remember what the first derivative test says? Well, draw in what a decreasing function might look like. So it's just kind of moving down. And then at x equals 2, it stops decreasing, kind of flattens out, and then starts increasing. So on the other side, it's going to look something like, get the pen working here. There. And so if we kind of draw in that really crude, rough sketch of what f might look like, decreasing on one side, increasing on the other, that tells us, yeah, local min. What about these other two graphs? Well, both of these are neither. Not a max, not a min. Even though x equals 2 in both cases is a critical number because the derivative, the graph flattens out there, so the derivative is 0. What would have happened though? What would have our sign chart looked like, say, in this example? We would have plotted x equals 2 because it is a critical number. So the derivative is 0 there. And we would have looked at, okay, what is f prime doing on the left side and what is f doing on the left side? So, we would have possibly found, well, based on this graph, f is increasing, so the slopes are positive. And on the other side, the graph is increasing, and the slopes would be positive there. So if we didn't have this picture to kind of look at, what we would have identified is we first would have found the critical number, because the derivative is 0 there. Then we would have figured out what is the sign of f prime, positive on both sides, and then we would have figured out, okay, what is the original function f doing? It's increasing on both sides. And so a way to kind of remember that if we're not seeing this sign change, we're not seeing a sign change here, what the graph would look like is, something, it's increasing on both sides. So just really rough. It's not a max or a min. And so we're going to be producing these sign charts. If we go from positive to negative, we have a local max. We're not going to have the picture to help us, so kind of draw in what you think the picture would look like, and as a way to help remember that it's a local max. And if our f prime changes signs from negative to positive, like we're seeing over here, well then draw in what the picture might look like to help remind you that that's when we have a local min. And if we go from positive to positive, and this really isn't too good. Let's try that again. Be like something, I don't know, something like that. You could do a better rough sketch, but you get the idea. We're increasing, temporarily flatten out, and then we're increasing again. So we're not drawing something that looks like we'd have a max or a min. And you'd see the same thing over here. If we were going to do the sign chart over here for this one, x equals 2 is something special, but what we're seeing is that the derivative is negative on both sides. So again, it's not changing signs, so it's not a local extreme point. It's neither. All right, so this is the first derivative test. Why? Involves f prime. Well, we're also going to see the second derivative test, which involves f double prime. So we'll see that next.